Today we will be discussing questions on this topic of atomic structure and periodicity. The question GATE XLP 2020 and the question number is 4. First, let us state that what the question is asking about. The question states that the azimuthal quantum number L of an electron in the dz² orbital of a copper atom, atomic number 29, is. So in the question, what has been asked is to find the azimuthal quantum number, that is L. So first, let us look into what are these quantum numbers mean. Okay, there are four quantum numbers. A total of four quantum numbers are used to describe completely the movement and trajectories of each electron within an atom. The combination of all quantum numbers of all electrons in an atom is described by a wave function that complies with the Schrodinger's equation. So in Schrodinger's equation, if you remember, there is a wave function, and in the wave function, it comprises all these four quantum numbers. So these quantum numbers are like the address of an electron inside an atom. So if one wants to find where an electron is present, inside an atom. So if you know these four quantum numbers, you can easily tell that. Okay, so what are these four quantum numbers? So the first one is the principal quantum number, or which is also denoted by n. The orbital angular momentum quantum number, also denoted as L. The magnetic quantum number, denoted as M. And the electron spin quantum number, that is the ms. What is principal quantum number? Principal quantum number n as actually stating the size of your atom or the size of your orbitals which are present. The size of the overall size of your means orbital is the idea is given by this n value. Okay, now if we go more deeper into the n and go into the subcell level, then the orbital angular momentum or the azimuthal quantum number plays take part role. Okay, so this L value is defines the number of angular nodes which are present. So if your L value is 0, which is case of the S subshell, then there are no nodes present. Means this angular momentum quantum number or this azimuthal quantum number gives you the idea of the shape of your orbital. Just like principal quantum number gives the idea of size, this azimuthal quantum number gives the idea of the shape of the orbital. And if on the basis of the different values of this L, the azimuthal quantum number, you have different subshells which are present, which have this particular L values. For S subshell, which is spherical in shape, the L value is 0, which means it does not contain any nodes. L value is 0 means it does not contain any nodes. That's why it is in a S subshell or a spherical subshell. P subshell, the L value is 1, means there is only a one node present, which means the P has a shape of dumbbell shape. Similarly, the D and F values are 2 and 3. So this is about azimuthal quantum number or L. Then we have an important equation which will be useful to solve this kind of questions, where there is a relation between the orbitals, the number of orbitals in a subshell, and the L value, that is the azimuthal quantum number, that is given by 2L plus 1. Magnetic quantum number m defines the orientation of an orbital. So this m value, magnetic quantum number, it defines the orientation of an orbital. S, the spin quantum number, it defines the spin. Either your electron can move in a clockwise direction or in an anti-clockwise direction. Either it has a plus half spin or a minus half spin. So these four quantum numbers are very important in defining the electrons in a atom. Okay. Now this slide is very important for solving this kind of questions which comes from this topic. First, what you need to do is to find the principal quantum number. For finding the principal quantum number, what is very important is to know the electronic configuration of an atom or an element. Okay, So once you write the electronic configuration, then only you can actually find out the n value if it is not only given in your question. First you need to find what is n, then what if someone asks you what is the L value, then just once you find the n value, subtract 1 from it and you will get to the L value. The magnetic quantum number m is minus L to plus L, and the spin quantum number ms is either plus half or minus half. So here it is given that if your L value is 0, then the m is also 0 because it is minus L to plus L, so it is 0. P orbital is 1, so it is minus 1 to plus 1, minus 1, 0, plus 1. D orbital, it is minus 2 to plus 2 because the L value is 2. So in this way you can actually calculate the amount of the m value, L value and n value. Okay, and S is not dependent on the previous three quantum numbers. It is either plus half or minus half. Now let us try to solve this question. So this question is asking to solve the questions. The asking is to find out the value of azimuthal quantum number or the L value. Okay, so what you need to do is that first you need to write the electronic configuration of the copper atom. That is, Ar means argon. Argon has an atomic number of 18 and the atomic number here is given 29. So then 4s1 3d10. How we are writing 4s1 3d10? You should follow n plus L rule. N is the principal quantum number and L is the azimuthal quantum number. If you add those two, you will get a value. If that value is higher, this means that your total orbital is in a higher energy level. Okay, so this 4s, if the value is 4 plus 0 is 4. 3 plus 2 is equals to 5 for 3D. So first, if there is a if you need to remove any electron, first you need to remove from 4s. Okay, and also while filling the electrons, you need to first fill 4s, then 3d. Okay, so this is the electronic configuration of copper. Now in the question it has been asked that what is the azimuthal quantum number of that electron which is present in this dz2 orbital, means which is present in this d orbital. So what is the quantum number, principal quantum number of d orbital? First that we need to find out. That is 3 here. So the first you need to find out that, then we know that what is the azimuthal quantum number formula, that is 3 minus 1, that is 2. So the answer of this question will be 2. For your future reference in the atomic structure and chemical bonding or the atomic structure and periodicity, I have referred two courses from NPTEL. First course is by Professor K. Mangla Sundar from IIT Madras, and the second course is by himself only. So you can look into these two courses for getting better insights about the atomic structure and chemical bonding and periodicity topics.